Hey guys, back again on Friday here. I'm going to run through the process to add and subtract on this video. I'll break it up and then I'll do a second video on multiplying and dividing with scientific notation. I think the adding subtracting is actually a little bit more complicated, but we'll go through that now, all right? So I gave you guys the reteach here and it runs through what you need to do. All right, but let me run through this kind of with my notes here. So what we're doing is adding and subtracting when we have two numbers in scientific notation. What has to happen, the 10 to the power has to be the same. If it's not the same, we need to adjust that. So if it is the same, it becomes really, really simple. All we have to do then, using our distributive property, basically think about it, it was like 5.6 plus 10.1 times 10 to the 8th, and you distribute that in. All we got to do when this guy's the same, 10 to the 8th, 10 to the 8th, is add these guys together. 5.6 plus 2.1, and I would get 7.7 times 10 to the 8th. I just bring that guy down. Okay, so if these guys are the same, you just add. The one thing you have to be careful with, though, is when you're done, your number has to be in scientific notation. Remember, it's got to be one digit, then your other digits times 10 to whatever power. So sometimes when you add these, you end up with a number that's not in scientific notation. For example, this one here, 9.8 times 10 to the 6th plus 4.6 times 10 to the 6th. By the way, these parentheses are there just kind of visually to break them apart. They really mean nothing because you would multiply first anyway. You would multiply first according to order of operation and then add. They're there just sort of to break these numbers up. So therefore, since I have 10 to the 6th and 10 to the 6th, if I pull that 10 to the 6th out, I'm adding 9.8 plus 4.6. I add them together, I get 14.4 times 10 to the 8th. Sometimes you'll see the X in the middle, sometimes you'll see a raised dot. Now I can't stop here because 14.4 is not in scientific notation. So therefore, I'd have to move it over one more place, okay? And I would end up with 1.44 times 10. Now think about it. If I move this guy 8 units to the right, if I moved it over one more, now I have to move it 9 units to the right for it to be the same number. Okay, and that would be my solution. And by the way, if you did this on the calculator, you would get this. You would get the answer. It's going to give it to you in standard form. So 9 point. Whoops. Let me turn it on. 9. There's a glare there. Let me take it out of the glare. 9.8 times 10 to the 6th power, up caret 6. I get out of there, plus 4.6 times 10 to the 6th power. That's the same example. I hit enter. Notice it gives it to me in standard form, but if I took that in standard form, it'd be 1.44 times 10 to the 1, 2, 3, 4, 5, 6, 7th power, the same thing that we got this way. All right, now the reason, you might be saying, why don't I just do all this on the calculator? Because if you're on the state test, we're not gonna have a calculator if they talk about scientific notation, okay? They want you to understand what you're doing with your decimal point as you move it back and forth. Subtraction's basically the same thing. Okay, except for instead of adding, I'm going to be subtracting. But what happens if the 10 is not to the same power? That's where we need to adjust one of them to make them to the same power, just by moving the decimal point and adjusting one of the exponents. It doesn't really matter which one. Okay, in the end, we're going to get the same answer. So in this problem, I have a 10 to the 5th and a 10 to the 4th. All right, so since I have a 10 to the 5th here and a 10 to the 4th, I'm going to make this guy a 10 to the 5th, which means, okay, again, it becomes logically speaking. Right now, I'd move this over 4 places to the right. So if I move the decimal point over one more to get it this way, I'd move it 5 places to get to the same number. So therefore, this guy is 0.32 times 10 to the 5th. If you don't get that, you can write this out in standard form this way, 3.2. So times 10 to the 4th would be 1, 2, 3, 4. And now I can rewrite this then in 10 to the 5th mode, which means I'd move it over 5 places, 1, 2, 3, 4, 5, and that's how I get that 0.32 times 10 to the 5th. This is the same as that. Now, since I have 10 to the 5th and 10 to the 5th, I bring that 10 to the 5th down, and I would do 5.08 minus 0.32. Remember, when you add or subtract, you line your decimal points up, and then you just add or subtract. So 5.08 minus 0.32, I line up my decimal points. 8 minus 2 is 6. I have a bar. This guy becomes a 4, 10. 10 minus 3 is 7, and then 4. So 4.67 times 10 to the 5th. Again, this guy's done. It's in scientific notation. I don't need to adjust it at all. So looking at your reteach then, on the 4 that are here, okay, so this first one, I'm gonna write over here, 1.2 times 10 to the negative 3rd plus 8.3 times 10 to the negative 3rd. Okay, this is pretty simple. They're both 10 to the negative 3rd, so I just add 1.2 and 8.3. So 1.2 plus 8.3 is gonna get me a 5. Notice I line these up, 9.5. Whoops, a 10 to the negative 3rd is supposed to be right there, sorry. And this would just get me 9.5 times 10 to the negative 3rd power. And we're good. Okay, the second one on the reteach, I have 9.3 times 10 to the 9th minus 6.7 times 10 to the 9th, which is real nice. They have them in both 10 to the 9th. So I just do 9.3 minus 6.7. All right, I'm gonna get 6 here, and this became an 8. 8 minus 6 is 2. 2.6 times 10 to the 9th power. Scientific notation, we're done that one. Now to get a little more challenging here, number 3 is 4.5 times 10 to the negative 5th power plus 4.5 times 10 to the negative 4th power. All right, now a couple options. If you're really confused, you can write this out in standard form, move it over 5 places that way, write this guy out in standard form, move it 4 places over that way, add them together, and then rewrite it into scientific notation. All right, or, I'm not sure what my dog's barking at there, or I can adjust one of these and move it around. So think about it. Let's go to, let's make this guy a negative 5th power. So if I'm gonna take this and move it to negative 5th power, so right now I'd move it 4 places that way. So if I want the same number, right, then I have to move it over 1 more this way, and this becomes 45 times 10 to the negative 5th. Okay. All right, then my decimal point would be here, and I'd move it 5 places, the same as moving it 4 places here. So this guy stays the same, 4.5 times 10 to the negative 5th. And now, since they're both to 10 to the negative 5th, I can add 45 and 4.5. That's going to get me 49.5 times 10 to the negative 5th. Now be careful with this guy, because at this point, this is not in scientific notation. So right now I'd be moving it 5 units to the left. So if I move it over 1 more, I'd only move it 4 units to the left to have the same number, times 10 to the negative 4th power. All right, and let's just do a quick check on that on the calculator. If I were to plug that guy in, I'd end up with 4.5. I'm going to start from the beginning. 4.5 times 10 to the, what power did we have? Negative 5th. I'm typing in the original problem. Plus 4.5 times 10 to the negative 4th. All right, so I hit enter, and you see I get the value. Now, if we put this in scientific notation, I move it over 1, 2, 3, 4 units, 4.95 times 10 to the negative 4th. Okay? And then the last one here on the reteach was 8.5 times 10 to the 10th, and minus 5.3 times 10 to the 9th. So once again, I need to adjust this to make one of them the same. So let's make, if I'm going to move this guy 9 units to the right, all right, if I want to now move it 10 units to the right, I move it over 1 place this way, 5.53 times 10 to the 10th, right? That would move it this way 10 units, that way 9 units, it's the same number. 8.5 times 10 to the 10th. So once they're the same, I go ahead and do the math. 8.5 minus 0.53. Remember, we can line these guys up, add a 0, that becomes a 7. This guy becomes a 4, and a 7 there. 14 minus 5 is 9, and 7. 7.97 times 10 to the 10th power. That's in scientific notation. Let's just do a quick check on the calculator. 8.5 times 10 to the 10th minus 5.3 times 10 to the 9th. Hit enter, and this guy gives it to me right in scientific notation already, and that's the answer that we got. 7.97 times 10 to the 10th. All right, so again, you have some options. You can always go back to standard form and then readjust moving your decimal point if this is confusing to you. Or you can just recognize if you're moving it one way, how you're going to adjust that decimal point. Just think how you get back to that same number. All right, I will stop here, post this video, and then go into the multiplying and dividing.